In the world of fabrics, a silent battle is being waged, one that could shape the future of fashion and sustainability. On one side, we have polyester, a synthetic powerhouse that has dominated the textile industry for decades. Known for its versatility and resilience, polyester has become a staple in wardrobes around the globe. On the other side, a new contender is emerging, polylactic acid or PLA, a bio-based plastic with aspirations of a greener future. PLA is derived from renewable resources, positioning itself as an eco-friendly alternative. Both materials are vying for a place in our wardrobes, but their journeys from raw material to finished garment are remarkably different. Polyester's journey begins in the oil fields, while PLA starts in the cornfields. Understanding these differences is crucial for consumers who are becoming increasingly conscious of the environmental and social impacts of their clothing choices. The decision between polyester and PLA is more than just a fabric choice. It's a statement about values and priorities. Polyester, derived from petroleum, has long been celebrated for its durability and affordability. Its ability to withstand wear and tear makes it a favorite for everyday clothing and activewear. However, its production process raises significant concerns about fossil fuel dependency and harmful emissions. The environmental cost of polyester is a growing issue that cannot be ignored. PLA, on the other hand, is often touted as a sustainable alternative because it's made from renewable resources like cornstarch or sugarcane. This gives it a smaller carbon footprint compared to traditional plastics. But PLA has its own set of challenges, including questions about its biodegradability and its reliance on agricultural land. The debate over whether PLA is truly sustainable continues, as it competes for resources that could be used for food production. This essay delves into the intricacies of polyester and PLA, comparing their production processes, environmental impacts, costs, and performance characteristics. By examining these factors, we can better understand the trade-offs involved in choosing one material over the other. By examining the strengths and weaknesses of each material, we can make more informed decisions about the clothes we buy and the future we weave. The choice between polyester and PLA is not just about fabric. It's about the kind of world we want to create. This is not just a simple comparison of two materials. It's about understanding the complex relationship between fashion, technology, and sustainability. The future of fashion depends on how we balance these elements. As we grapple with the environmental consequences of our consumption habits, the choice between polyester and PLA represents a microcosm of the larger challenges and opportunities facing the textile industry today. The decisions we make now will shape the future of fashion and its impact on our planet. Let's step behind the scenes and delve into the fascinating world of fabric creation. Today, we will explore the intricate processes behind the making of two popular fabrics, polyester and PLA. Polyester starts its life as crude oil, a fossil fuel extracted from deep within the earth. This oil undergoes a complex chemical process involving several stages to transform it into tiny plastic pellets. These pellets are then melted at high temperatures and spun into fine fibers, which are subsequently woven or knitted into various types of fabrics, ready for use in countless products. PLA's origin story is quite different and more rooted in nature. It begins with renewable resources like corn or sugarcane, which are cultivated and harvested. These plants are processed to extract their sugars, a crucial step in the production of PLA. Through fermentation and a series of sophisticated chemical reactions, these sugars are converted into lactic acid. Lactic acid molecules are then meticulously linked together to form long polymer chains, creating a bio-based plastic known as PLA, which can be used in a variety of applications. The stark contrast between their raw materials, fossil fuels for polyester and renewable plants for PLA, is the first clue to their divergent environmental impacts. Polyester's reliance on non-renewable resources raises significant concerns about resource depletion and the environmental consequences of oil extraction. PLA, while seemingly more sustainable at first glance, presents its own set of challenges, particularly in terms of land use and the potential for competition with food crops, which could impact food security. When it comes to environmental impact, polyester and PLA present a complex picture. Both materials have their own sets of advantages and disadvantages that need to be carefully weighed. Polyester's reliance on fossil fuels makes it a significant contributor to greenhouse gas emissions. The extraction and processing of these fuels are energy-intensive and environmentally damaging. The production process is energy intensive, releasing harmful pollutants into the air and water. These pollutants can have long-term effects on both human health and the environment. Additionally, polyester is not biodegradable, meaning it can persist in landfills for hundreds of years. This contributes to the growing problem of plastic pollution, which affects wildlife and ecosystems. PLA, being derived from plants, is often marketed as a more eco-friendly alternative. It is made from renewable resources like cornstarch or sugarcane, which can be replenished over time. Its production process generally has a lower carbon footprint compared to polyester. This is because it relies less on fossil fuels and more on renewable energy sources. PLA is also biodegradable under specific conditions, meaning it can break down into natural components over time. This can help reduce the amount of waste that ends up in landfills. However, PLA's biodegradability is not without its caveats. It requires specific conditions to break down effectively, which are usually found only in industrial composting facilities. It requires industrial composting facilities, which are not widely available. This limits the practical benefits of its biodegradability for many consumers. In regular landfills, PLA can take decades to decompose, and it may even release methane, a potent greenhouse gas, during the process. This undermines some of its environmental benefits. Furthermore, the cultivation of crops for PLA production raises concerns about land use, deforestation, and the use of pesticides and fertilizers, which can have negative impacts on ecosystems. These agricultural practices can lead to soil degradation and water pollution. The environmental equation for both materials is multifaceted, requiring careful consideration of various factors beyond just their origins. It's essential to look at the entire life cycle of these materials to make informed decisions about their use. To conventional plastics like polyester.